So today we are going to look at the part 2 of how to learn machine learning faster and more productively. That is, it's not just learning it, but actually to be more productive as you learn, which is part of our important clarification series. With the team, always let the data speak. And our aim and objective, our aim is towards making AI and machine learning accessible, ethical, and life-changing because of the unique capacity and capability that AI and machine learning portend in this era. So as I used to say, we can no longer ignore AI, irrespective of our field of specialization. So today we're going to continue from where we stopped the other time, how to learn machine learning faster, that is making it faster, and you can start your practice as soon as possible. One of the best way to learn machine learning is to practice as you learn. Don't wait until you've attended several lectures. No, the little, try to put into practice. And then as you practice, you face issues, and then you see clarification, and then you keep building it. Within a couple of hours, you build your first model, you start having a practical idea of, okay, this is what they are talking about here. This is what we encourage us. There is the standard procedure, iterative machine learning model building framework. That is, data is very important. Without data, you cannot do anything. And the good news is data set is everywhere. They are wasting away. Your past data, you can take benefit of the past data. You see it? Through machine learning. So you can get data set, make it available in the proper format. Then you move on to the next stage. There are so many things you can do here. We'll cover that later. But if your data, format it in an Excel format, in column, preferably you put the last column should be what you want to predict. For example, I want to predict if someone is going to have diabetes or is already having diabetes or hypertension or whatever. You want to predict the next intrusion, who is going to be the next cyber attack that will happen, from which country, at what time. There's so many things you want to predict depending on your area of interest. Or as an engineer, you want to predict the strength of material. So once you have your data, you move to the algorithmic phase. You do the data modeling. That is, you check the performance. You can always go back. So there's no need to do too much preprocessing. You can always go back. If your result is not satisfying, change hyperparameter optimization, move forward. You may also go back, change the algorithm. Sometimes after hyperparameter optimization, it's not working to your satisfaction. Change the algorithm. Initially, you were using k-nearest neighbor, KNN. You can change it to decision tree. You may change it to support vector machine. Try several algorithms. And that is the good thing about machine learning. No single algorithm is better in all situations. The fact that somebody uses in his previous project and KNN work doesn't mean it's going to work for you. So you have that liberty to change. Check what that is in line with our principle of let the data speak. Let the data speak. You can't force performance on algorithms. No. So you have to check which algorithm will be able to understand the nature of this data set, because every data is coming with their own uniqueness. We have to check that as the case may be. And then the next is, as you keep changing, sometime after changing the algorithm, it's still not okay. You may have to go back to the data stage, do more preprocessing. Maybe I need to normalize my data. Normalization sometimes make you get better results. However, don't normalize data initially, because you may lose the important insight. We have seen people who did it before. They later realized that they have done something wrong. They got the data, normalized it, and they were not getting good results until they let the data speak. First of all, you use the raw data. Don't normalize it at the beginning. Use it as much as possible. And then when you are not getting what you want, go back and normalize. Sometimes you may need to find a logarithmic conversion of your number. There are a lot of pre-processing you can. We will show us more of such later. But know that this is the basic system you need. Data, algorithm, and modeling. Data, algorithm, and modeling. You have your data, you have your algorithm, you have your modeling, which is very, very important as the case may be. Now, how to learn machine learning faster and productively? We put up a couple of quick way of making us to learn faster, especially as more people are joining. Don't worry. If you are joining for the first time, you are welcome. And you can learn faster than you ever expected. For those that joined us recently or still struggling to catch up, I recommend you first start by watching the following 4 revision videos from our channel. You see them there. This document has been provided before. We are going to provide it again for the sake of those people who just joined. Watch this video. Is about machine learning, introduction to machine learning, what it is, how to use it. By the time you are done with first and second, you have a very clear understanding of what we're talking about when you talk about machine learning. And then as you are watching, please keep note of clarification to be made, okay? You are free. This is the essence of having this weekly program so that new people, when you watch the video, you have questions you want to ask, then you can ask them. And that's why our first section is going to be for some minutes. After we are going to go into question and answering section. So always note down whatever question that may arise as you are watching the video. So part 1, part 2, part 3, part 4. By the time you are even done with 1 and 2, you can move to the next stage of trying to practice what you've just listened to, which is going to be the next slide. So this video series is in 4 parts. You can watch it for a layer. By the time you are done, you will have, this will support you to learn the basics as soon as possible. However, you're always free to contact for further clarifications and questions that may arise. So this is very important point to take note, and you can bring it to our live sections every Saturday, and you can also communicate personally one-on-one for quick and urgent clarification so that you don't get stuck. So once you are done with this introductory video, then you move to the next, which is after watching the 4 videos earlier provided, which is general introduction to machine learning concept and techniques. It is now time for you to learn practically how to build your first ML-based model. See? So, and then you follow this video. It is 3 parts. You have part 1, you have part 1, you have part 1, you have part 2, and you have part 3. By the time you start with the part 1, it's a practical demonstration in weaker environment. You see, we call it Hello World from Machine Learning Model. It's easy for you to follow. Within 2.5 hours, you'll be done with all this introductory. This video, these 4 videos, they are less than 2 hours together. Why? This one will take you another couple of minutes. Then you start practicalizing what you've learned. So these are the 2 stages. Stage 1, try to understand what is machine learning. Watch this video. We really made it because we can now be going back to basic introduction for everybody that joined. But once the videos are made very easy to follow. If you have any issue, just note them down, and then you can then correspond and then clarify in our live session or any other channel. So you watch the part 1 video, which will teach you or demonstrate how to run your first model in weaker environment. The weaker environment provides you with the opportunity to learn without writing a single code. It's a free software, free package. You can download it easily. Just search for Weaker download. So from the Waikato University. Yeah. So once you are done with that, then you will have successfully built your first model, as the case may be, as the case may be. Next, again, we mentioned that you should always feel free to seek for clarification if anything is not clear as you launch yourself into it. Now, after that, I want to call our attention to the fact that there are different angles to solving problems using machine learning through AI-based solutions. If you are people from diverse backgrounds, maybe from engineering, chemistry, biology, any area of your interest, think and brainstorm about your area of specialization or interest and see how you could utilize machine learning modeling towards improved outcomes, how you can get things better in your area. Things that you can do that takes a lot of time. Sometimes you don't have an idea of how it's going to go. You can bring in machine learning, use the raw data that is wasting away, use it to build a model that can predict something for you. For example, in engineering, you want to predict strength of material, which is going to take you time in your laboratory. You have data in the past 20-something years, you have been working on different data sets, gather those data sets, use it to train your model, and then you can come up with a program that can predict the strength of new materials even before you go to the laboratory, which will make life very easy. Instead of spending 2-3 weeks in the laboratory just to test the strength of one material, the AI system will give you the strength of material within twinkling of an eye. Furthermore, you think of how you can improve upon your earlier achievement through coming up with more advanced machine learning algorithms or techniques like hybrid or ensemble modeling, as the case may be. Meanwhile, to those people who are from computer science related background, your work is to support people, to help people come up with ideas that can make life easy for every other person in other fields of endeavor. First and foremost, you clearly think and brainstorm about areas that may be in dire need of improved outcome. If provided with machine learning modeling capabilities, then you can step in. It's not your area, but then you look at their problem. You can solve this problem in a better way than what you are currently doing. That's one of the power of machine learning and data analytics. You see, I remember there was a case of a drilling operation in oil and gas, where people were using 3 parameters, very important parameters were being monitored. But after using machine learning modeling to identify the best parameter to be used, they were able to come up with one from these 3, another one from ignored parameters, making only 2. One from these best 3 they were monitoring, plus one from the one they thought were not important. So machine learning was able to identify these 2 very important hyperparameters for modeling and be able to determine drilling operation. And they started getting better results than what they were getting before. This is the power of machine learning. What ordinarily human beings may not be able to come up with, machine learning based on data, previous data. It would run a lot of simulation, trying to come up with, okay, identify what are the parameters that are variables that are most important for what we are trying to estimate. So further think of how you can improve upon your earlier achievement through producing more advanced machine learning algorithms, based solution or techniques like hybrid, ensemble. Also, you may even come up as a computer science person, you may come up with new machine learning algorithms, totally new, that is not existing, or new hybrid or ensemble framework that were previously unknown. These are the 2 different angles you can approach it. Either you are from computer science background or you are from the background of other fields. Everyone can relate easily. Now, here then we show you what I call the modified iterative machine learning modeling framework to support let the data speak principle. So the same thing I showed you earlier, you have the data. So you can prepare the data. How much of preparation is necessary or pre-processing? Do the minimum that you need to make the algorithm accept your data. You see, for example, if there are missing values, if I want to use decision tree, I can still use that data. Despite the missing value, I can use the data because decision tree has inbuilt capacity for handling missing value automatically. So I don't need to do missing value treatment if I'm going to use decision tree family of algorithms. However, if I'm using algorithm like support vector machine, it may not allow me to use data set with missing value. In that case, missing value treatment becomes compulsory. So you do whatever is compulsory at the initial minimum that is compulsory for you to run the model, and then you move to the algorithm stage, data modeling. Run the experiment, check your performance, then you can go back here. You may go back here, and then you may also have to go all back to the data. If you go back here, these are some of the stuff you can do here. You can do hyperparameter optimization here. You may have to, that is, changing the algorithms. In the worst case, when things are really very tough, you are not getting good results, you may have to go to making ensembles, making hybrids. That is, selecting algorithm, building a new algorithm, combining multiple algorithms together to do the work for you. However, we recommend that you do this after playing with some pre-processing stages that may give you good results without spending more time. Because to build hybrid and ensemble takes a lot of time. So it's not something you go for quickly. So once you do the hyperparameter optimization, which is compulsory, this is a must. You must do it. That is when I pick k-nearest neighbor as an example, KNN, I start with k is equal to 1. I run the experiment. Maybe I'm getting like 86% accuracy. Again, I try k is equal to 3. And you have to do this, is called hyperparameter optimization. It's compulsory. You have to do it. Once you are done with that, then you may have to change the algorithm. Maybe KNN, after all the hyperparameter optimization, you are not getting acceptable result. You want more. That is fine. Change to decision tree. Change to support vector machine. But for every algorithm, you must do hyperparameter optimization. It's compulsory. If you don't do it, your modeling is not valid. It's not valid, especially when you want to compare algorithms together. You did for one, you did do for the other, and you say A is better than B. That is not fair. You have to do the same thing for all the algorithms. After that, you can change the algorithms to others. However, making ensemble and hybrid should not be done at this level. So if you don't get what you are looking for in terms of performance, you can go back to feature engineering. Maybe I need to create more feature. Maybe I need to combine some feature. Maybe I need to do feature selection. You are using like 50 features, too much. And you have only 1,000 samples. The more the feature, the more the samples you need. But samples are usually limited. So you may have to do feature selections. You may have to do normalization of your data. You can see so many things we can do. You can do feature selection. You can use feature reduction using PCA. We may have to do data transformation to improve your result, like normalize the data, log transform the data. You see? So construct new attributes. Sometimes you may have to use existing attribute to construct another attribute. All these are other feature engineering. Data cleaning, undo missing value, come back again and do outlier treatment, reduce noise. So many other pre-processing stages you can carry out. However, once you do one pre-processing act, run the experiment, and note down the results, because it's very, very important. It's very, very important. You don't know which pre-processing stage will actually give you a better result. So that is why when you do too much pre-processing, it may lead to what we call data mutilation. Data mutilation means that you have destroyed the data. You are not going to you keep getting bad results, despite the fact that you are making a lot of efforts. So that is why we recommend one preprocessor at a time, then you run the experiment. This is why we recommend multi-channel pipeline. You see, multi-channel pipeline. So keep running the experiment to check if you are still on course. If that preprocessing does not work, you may combine another preprocessing and then check again. By so doing, you are not going to miss out on any preprocessing that will give you good results. Again, this is in line with the principle of let the data speak. So always remember this aphorism and this statement, always let the data speak. And the idea is summarized thus: start with raw data set before applying too much preprocessing to avoid data mutilation. Because we have seen cases where people did a lot of preprocessing. At the end of the day, they were not getting good results until we asked them, where is the original data? It has been totally taken away. The data they are using is far, far different from the original data due to too much preprocessing. And I said, bring back the original data, run the experiment, and to God be the glory, we started getting good, excellent results. So that is the principle of let the data speak. Always use the iterative process idea. You can go back. So there's no need to do 20 preprocessing before you start modeling. You can always go back. That is why you have, this is a generic machine learning building framework. You can always go back. So there's no need to do too much preprocessing before you check the modeling. One preprocessing, check the modeling. Another one added, change the process until you are able to get what you are looking for. Remember, machine learning is not a dogma. Try different algorithms and options. Dogma is something that doesn't change. The fact that your friend used support vector machine on his data or our data and is getting 99%, it doesn't mean when you use it on your own data, you will get 99%. No, it's not a dogma. It is only dogma that doesn't change. So always let the data speak and take the next step based on what you can deduce from the data modeling outcome so far. This is where experience matters. So as it goes really complex, you may need to seek the experience, the expertise, consultation of experienced expert who will guide you. Okay, you have tried this, go and do this, go and do this, so that you can achieve the envisaged accuracy or human objective of your project. In addition, we've also built other learning resources. The same thing that we are already provided for you all. For some people, they like a course that is curated together, that is ready. The same thing you can get from here, those videos here. We've also put together something similar. Let the Data Speak. It's a book that has been written to guide us through the idea of letting the data speak so that you do the writing. The second material, this is where you have all the earlier videos. You can take the video directly from our YouTube channel, and you can also take a very simple course here, which is a 2.5 hours crash course with Weka. So perfect for beginners. So you can get it from here, Seller. This course is also on Udemy, where you have quizzes and some question and answer to try and check that, okay, are you in line with what you are doing? So this all also there. Writing machine learning based research paper. For those people who are in the academics, you can check this one out also. So we have how you can master the structural ML research papers, how to run, and there is also, therein you find the template, word template of how you can write your research paper based on experiment done in machine learning. You also have it in Stellar, and you also have it in Udemy platforms, whatever one you are comfortable with. And I'll take us back again to our iterative machine learning modeling. Always remember, it's very straightforward. You can do it. Don't say I done recently. Everybody can do it. But what you need to do is to seek for a way for you to practicalize it. You see, a quick look at a few case studies and possible tasks. Let's say you want to predict diabetes. You are going to use as a quick example this morning. Hypertension prediction, bankruptcy, medical and biomedical related predictions. There are so many things you can do in this respect. What of health and wellness? You want to know your status in terms of type 2 diabetes risk. You want to know your health, the status of your heart. So you want to predict the risk of a heart attack or stroke in the next decade based on cholesterol, blood pressure, and lifestyle. Your fitness goal, are you going to achieve your fitness goals based on particular parameters? What of sleep quality forecast, illness susceptibility, what of your personal finance? You want to have a month-end prediction, saving goals prediction. Are you going to achieve your goal? If you continue with this characteristic, with these habits, what of subscription waste? And host of other things that ordinarily as human being you cannot relate with, you may not be able to have an idea, but there are data sets that are with you, your habit, your characteristics that can actually relate with this. So you can build a simple machine learning modeling that can relate with whatever area you are actually dealing with. And that goes to any other area of specialization that you may be interested in. Let's say, for example, the diabetes prediction. Let's say, for example, the diabetes prediction. In here, so you go to the weaker environment. I'm now weaker environment. You click Explorer. When you click Explorer, then you're going to have the Explorer open for you. The Explorer is open. You can see here, you can't do anything here because it's gray out. You need to open, the first thing is to load your data. So open your file. I click open file. I have my document here. We're going to use the 2025 machine learning training data set. Okay, click the link. You can see, even though I have data set there, there's nothing here because the file type that Weka is looking for is ARFF data file, .ARFF. My data set is in the form of CSV. So you have to come here and indicate that I'm looking for CSV data. You see here. Then you see those data sets. You can see it brought out all the data sets that are in form of Excel. Once you have your data in Excel, then you can easily bring it into the Weka environment. So you can see here I have data set on absenteeism at work. I want to predict if somebody is going to be absent from work tomorrow or next week. Diabetes prediction based on interview data. I have hypertension also data set there. Permeability, there's stroke data. Let's deal with the diabetes data as an example. So now it has loaded the data because this data is trying to encourage what we call sustainable health predictive solution that everybody can relate with. Sometimes when people visit the clinic and they ask them to do some medical tests, people run away, they will not come back because they don't have the money to do the test. But with a questionnaire-based medical prediction, you don't need to go for clinic test. It doesn't cost you. Just tell us answer some basic questions. Age, gender, polyuria, polydysplasia, sudden weight loss, weakness, polyphagia, genital thrush, visual blurring, itching, irritability, delay healing. When you have any wound, does it heal quickly? Partial paralysis, muscle stiffness, obesity. And this is the prediction to know whether the person is positive or negative. Positive means he's suffering from diabetes, or you already have this diabetes silently, unknowingly. So based on these characteristics, we want to predict this. Very straightforward. We can also try to do feature selection later, where we're going to reduce the number of features. I want age, I want gender, because this is easy to determine. So do you experience sudden weight loss? What of weakness? Do you have itching? Do you have delay healing? I want to use those things we can relate with. I don't want obesity. I don't want to use obesity because to determine somebody is obese, you have to do some computation, some calculation, and every person in the village may not understand it. So I want to use basic stuff that are very straightforward. This one will need some medical explanation. So we remove those ones. Genital thrush. Okay, things that people can relate with easily. Yeah, I can remove them. So I'm removing all those. So I'm left with very easy to understand questions. Based on this 9 questions now, I want to run my experiment. So I go into classify and I choose the algorithm. We want to start with our lazy classifier, IBK. This is K nearest neighbor. And I click go. You can see with those simple features, we're able to predict somebody is going to have diabetes or not up to 94.6% accuracy. And that is just by default parameter. So I go here and I'm going to do hyperparameter optimization. I change my K from 1 to 3. And I can run the experiment again. You can see it has gone down to 89%. It means the best hyperparameter is 1 for this data set. When I increase the hyperparameter, it goes down. It has gone back to 94 when I made it into 1. Meanwhile, there's another hyperparameter that we can choose from, which is we can choose the hyperparameter. You see Euclidean distance. Can I use Manhattan distance or Minkowski distance? This is called hyperparameter optimization. We can check out our videos on how to carry out hyperparameter optimization. So this is a very simple demonstration of how you can use weaker environment to predict based on your data set that is already available. You arrange those data sets. They are in column. Age in column 1, gender in column 2, sudden weight loss, column 3, weaknesses. You put them in column. The class is the one in the most rightmost column. And that's why you're going to specify, because it's all data. People that you have interviewed, this person is diabetes, confirmed by doctor. This one is not having the disease. Once we have enough of people who have the disease and those who don't have it, like here now, we have 320 people that are suffering from diabetes and 200 people that are not suffering from diabetes. That is why we are able to build a model that can predict if somebody will suffer from diabetes or is suffering from diabetes or not. You need data for both cases. So this is just a very short demonstration, which I also believe once you watch those videos we already referenced to, you'll be able to make even more clarification, more sense of it. It will be clearer. And as you practice, do note down your questions or things that may not be clear. Again, I tell you, it is very easy to relate with. You're just joining, it's not a problem. There's always opportunity to learn. Once you follow those guidelines, you also become a pro within the shortest period possible. Thank you very much for listening. I believe it's time to stop for the day, and then we can take some questions if there are or there is. Thank you very much, and wishing you all the best.